10 students, how are you all? I hope you're doing amazing. This is your Ekta ma'am here. In this video, we are going to do a quick 10-minute summary of the chapter metals and non-metals. Now, what are metals? Metals have luster, they are hard, they are malleable. What does malleable mean? That means they can be beaten down into thin sheets. They are ductile, that means you can draw them into thin wires. They are good conductors of heat and electricity. They are sonorous, that means they produce sound. They have high melting and boiling point. Now, all metals do not follow these physical properties. There are some exceptions to this rule. And what are those exceptions? Sodium, potassium, both are metals, but they are extremely soft. Mercury, which is a metal, but it exists as liquid at room temperature. Cesium, gallium, these are metals, but they have really low melting point. You can melt them on the palm of your hands. Non-metals. Physical properties of non-metals include they are really soft, they are brittle, that means if you break them, they will break down into as powder form, right? Break into powder form. They are dull. Non-metals are dull. They are bad conductors of heat and electricity, and they have low melting and boiling point. But again, there are some exceptions to these physical properties also, which include iodine. Iodine is a non-metal, but it is highly lustrous. Graphite. Graphite is made up of carbon. It is an allotrope of carbon, right? It is a good conductor of electricity but non-metals are bad conductor of electricity, right? But graphite, which is made up of a non-metal, it is a good conductor of electricity. Diamond, it is also an allotrope of carbon. We will discuss them all in the next chapter, which is really hard, okay? Non-metals are supposed to be soft, but diamond is extremely hard. Now, the reactivity series. Let's start with the reactivity series first, then we will talk about the chemical properties of metals and non-metals. Okay, this is very important in regard to the chemical properties of metals. So let's start with it. Please stop calling me a careless zebra. Instead, try learning how copper saves gold, platinum. Okay, if you have any other mnemonics, you can follow that as long as you remember the reactivity series. That's all matters. So we'll start with potassium, sodium, calcium, magnesium, aluminum, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold, platinum. Clear? I hope you remember it now. Please stop calling me a careless zebra. Instead, try learning how copper saves gold, platinum. Now you will see how it is significant to it, right? Now, chemical properties of metal. Metals react with oxygen, and when metals react with oxygen, we get metal oxide. Metal oxide can be basic or amphoteric. What do you mean by basic oxide, ma'am? Because when you put metal oxide in water, we get a base, right? And amphoteric means there are some metals, for example, zinc, aluminum, lead, right? These metal oxides are amphoteric in nature. That means they react with both acids and bases. Displacement reaction. Metals also show displacement reaction in which a more reactive metal displaces a less reactive metal from its compound. For example, remember in the reactivity series, zinc was lying above iron, right? So it will displace iron from iron sulfate and will form zinc sulfate, and we will get iron. That happened because of the difference in reactivity between zinc and iron. Next reaction is reaction with acids. How do metals react with acids? So we have three acids that we will be majorly dealing with: hydrochloric acid, sulfuric acid, and nitric acid. With hydrochloric acid, sulfuric acid, metals react with them and they evolve hydrogen gas. If the metal are more reactive than hydrogen, remember all the metals lying above hydrogen in the reactivity series, they will displace hydrogen and we will get hydrogen gas. They all will evolve hydrogen gas. Okay, this is the order of reactivity: magnesium, aluminum, zinc, iron, lead. Now, how do metals react with nitric acid? It is a bit tricky. When nitric acid, there is one thing: nitric acid is a strong oxidizing agent. Now, it is a strong oxidizing agent. It does not evolve hydrogen gas. What it does, hydrogen gas, it does the oxidation of hydrogen gas. Hydrogen gas combines with oxygen and we get water, right? Only magnesium and manganese, they evolve hydrogen gas when they are treated with nitric acid. Why? Because only these metals are reactive enough. Rest all the metals, they do not evolve hydrogen gas when treated with nitric acid. Aqua regia. What is aqua regia? It is also called royal water. It is 1:3 mixture of concentrated 1:3 mixture of concentrated nitric acid and concentrated HCl, right? 1 part concentrated nitric acid, 3 part concentrated HCl, right? It is highly corrosive in nature. What is the purpose of making this then, ma'am? Yeah, the purpose is to dissolve gold, silver and platinum, as these are noble metals. They do not react with any other compound, so that's why it is made to dissolve all these metals, right? That is the purpose of aqua regia. Now, how do metals react with water? There are different level of reactions based on the reactivity series. If your metal is super reactive, like sodium, potassium, right, it will react vigorously with water and form metal hydroxide, and the evolved hydrogen gas will catch fire. Okay, so as soon as you put sodium or potassium in water, they will evolve hydrogen gas, they will catch fire, they react vigorously with water. Then you have some metals which are less reactive, right? Like calcium, and they will form metal hydroxide, but the evolved hydrogen gas will not catch fire because they are reacting moderately with the cold water. Now, some metal, now if we move down the reactivity series, we will see that the reactivity decreases for the metals, right? So what will happen? We need to increase the temperature, and that's why these metals react with hot water, like magnesium. They will form magnesium hydroxide and hydrogen gases evolve. Now, if you go further down the reactivity series, the metals are much more less reactive, right? And thus they will react with water vapors. Water vapors have a higher temperature, greater than 100 degrees Celsius, right? So those metals will react with water vapors. And what do we get? Metal oxide plus hydrogen. Why we are getting metal oxide and not metal hydroxide? The reason is metal oxides, they are more stable at higher temperature, while metal hydroxide is not stable at higher temperature. Metal hydroxide will decompose as metal oxide and water. Clear? That's why that's why we get metal oxide when we metals react with steam. Now there are fifth category, some metals like lead, copper, silver, gold, platinum, they do not react with hot water, cold water or water vapors. Why? Because they are not reactive at all. They are least reactive. Next, chemical property of non-metals. Now, non-metals also react with oxygen and they form non-metal oxide. Now, non-metal oxide, when combined with water, we get acid. That's why non-metal oxides are acidic in nature. But stop right there. Non-metal oxide can be neutral also, okay? For example, metal oxides can be basic or amphoteric, right? But non-metal oxide can be acidic or neutral. Acidic oxides include carbon dioxide, nitrogen dioxide, sulfur dioxide, and neutral includes carbon monoxide, nitrogen oxide, and water. Clear? Non-metals do not react with waters or acid. Just understand this. Bases, acids and non-metals both have same nature. Both wants to accept electrons, right? If both want to accept electrons, then who will donate? Because whenever a reaction is happening, one have to donate electron, the other have to accept those electrons. If both are the accepting nature, they will not form any bond. Thus, non-metals do not react with waters or acid. You can also explain it on the basis of reactivity series. So on the basis of reactivity series, if you go below hydrogen, the reactivity decreases, right? That means hydrogen is much more reactive than all the elements lying below hydrogen, right? Non-metals lie below hydrogen. That's why they are not able to react with water or acid, because both water or acid have hydrogen in it. Clear? Now, how do metals and non-metals react? When metals and non-metals react, we get an ionic compound because their nature is different. Metals want to donate electrons while non-metals want to accept electrons, right? So, a bond formation happened between them, and the bond formed is an ionic bond. How? Sodium, it is a metal, right? It has electronic configuration 281. It loses one electron, forms Na positive, sodium cation, and have electronic configuration 28. Its octet is complete. Now move on to chlorine, which is a non-metal. Chlorine gains this one electron and it needs one electron only. It has electronic configuration 287. It needs only one electron to complete its octet. So it will accept this electron and form Cl negative, and we get 288. The octet is complete. Now you can see there is a positive ion, there is a negative ion, there is attraction between opposite charges. So the kind of bond that is formed by the combination of NaCl is an ionic bond. We get NaCl, right? Na positive, Cl negative. The bond formed is ionic bond. Now what are the characteristics of this ionic bond or these ionic compounds? The compounds having the ionic bond are called ionic compounds. They are crystalline in nature. They have strong force of attraction because the attraction is the electrostatic force of attraction, right? And because of that, ionic compound, they exist in solid state and they are really hard. They are brittle, right? They can be broken into pieces by applying pressure. If you apply the pressure, they will break into powder form, okay? They have high melting and boiling point. Yes, because why? Because the force of attraction is really strong between the ions. They are good conductor of electricity in the molten state and in aqueous solution. In molten state means when you melt them, only in the molten state, or as when they are present in aqueous solution, they are conductor of electricity. Why? Because only in these states they have free ions. Electricity conduction happens via electrons or ions. Any one is needed, right? Either of them is needed. In case of solid state, in ionic compound, they do not have any ions, but when you dissolve them in water or you melt them, they have free ions, and due to these free ions, they will conduct electricity. They are soluble in water and insoluble in organic solvents like kerosene, petrol, right? Because water is polar in nature. It has poles, H positive, OH negative, right? And ionic compounds also have ions, Na positive, Cl negative, right? A positive ion and a negative ion, and because of that they are only soluble in polar compounds. Minerals versus ore. What are minerals? Minerals are those elements or compounds which occur naturally in our earth crust, right? They are occurring naturally in our earth crust, and that's why they are called minerals. For example, salt, clay, marble, all these are minerals. Now these minerals may or may not contain the metal in sufficient amount. We need to extract the metal. If we want to extract the metal, it may or may not be present in sufficient amount in minerals. That's where come the ores. Okay, what are ores? Ores are those minerals which contain a high percentage of a particular metal from which metal can be extracted profitably. They are called ores, right? What are the examples? Examples: aluminum is extracted from bauxite ore. Hematite is the ore of iron. Rock salt is the ore of sodium. Clear? So ores are nothing but they are just minerals having sufficient amount of metals in them so that you can extract metals from them economically and conveniently. Now what is gangue? Gangue is the unwanted impurities that are combined, that are present in the ore, okay? With the metal ore you have some impurities, right? These impurities are called gangue. For example, soil, sand, rocky materials, right? Any rubbish and garbage. Now how do you extract ores, right? Before extracting ores, you need to know the order of reactivity. So potassium, from potassium to aluminum, we have metals of high reactivity. There are different methods designed for the extraction of metals based on their reactivity. So metals of high reactivity includes potassium, sodium, calcium, magnesium, aluminum. Then metals of moderate reactivity include zinc, iron, lead. And metals of low reactivity includes copper, mercury, silver. And least reactive metals are gold, platinum. Now how do you extract these metals from their ores? So have a metal reactivity. If you have a metal of high reactivity, you do the electrolysis. Do the electrolysis of the molten ore, and after the electrolysis we get the pure metal. If we have a metal of high medium reactivity, if we have a metal of medium reactivity, so what will happen, my dear kids? Either it will be present in its sulfide ore or as its carbonate ore. If it is present as its carbonate ore, what will happen? We'll do calcination. Now what is calcination? Calcination is the process in which ore is heated in the absence of air, in the absence of oxygen, right? It is most commonly used to convert carbonate ore into oxide ore. So if you heat a carbonate ore in absence of oxygen, what will happen? We get metal oxide. Similarly, if you take a sulfide ore and do the roasting of sulfide ore. Now what is roasting? Roasting means you heat the sulfide ore, you heat the metal ore in presence of excess oxygen, in presence of excess of air, right? and it will convert the sulfide ore into again metal oxide. And after getting the oxide, you do the reduction. What is the reduction? Addition of hydrogen or removal of oxygen, right? So you remove the oxygen, and that's how you got your metal, and you purify that metal. Now if you have metals of low reactivity, they will be present as their sulfide ore. Again, we do the roasting, get the metal, and do the refining. Now there are metals of not reactive at all, which are gold and platinum, right? They will exist in their native state. They will exist as it is. Now one thing, concentration of ore. I've written it concentration of ore. What is concentration? It means removal of the gangue particles of all the other impurities except the ore. That is called the concentration of ore. Various methods are applied: gravity separation, frost flotation, magnetic separation, leaching process. That depends on the type of impurity, right, and the nature of it. Next, electrolytic reduction and electrolytic refining. These are very important, so understand them clearly. Electrolytic reduction is used to extract highly reactive metals: sodium, potassium, magnesium, calcium. Clear? So this method is used to extract highly reactive metals. And in electrolytic reduction, what do? We extract metals from their molten compounds. Majorly we have, mostly we have molten chlorides. So what do? We make an anode. We have an anode and we have a cathode. One anode we have, one cathode we have. Clear? Anode starts breaking down. The impurities collect in the salt solution, and impure metal rod breaks down, combine in the salt solution. From the salt solution, an equivalent amount of metal will get deposited on the cathode, and that is the electrolytic refining. So this will get consumed, and on the cathode you will get the pure metal, right? Here at the anode you get the chlorine gas, and at the cathode you get the metal. So at the cathode you are getting the metal here, and similarly at the cathode you are getting the metal here. But both processes are totally different. That was it. I hope you learned